So good day to all of you. I am discussing the chapter 6 of my module in thermodynamics. So this is the gas cycle. We're going to focus on the Carnot cycle of the gas cycle. So but first, there is 4 elements of a thermodynamic heat engine with the fluid as a working substance. Now the first element is a working substance, matter that receives heat, rejects heat, and does work. Meaning, an heat engine should have a heat acceptor, a heat rejector, and a engine that does its work. Now next, a source of heat from which the working substance receives heat. An heat engine needs a heat acceptor for a heat sink to which the working substance can reject heat. So, meaning that an engine must have a heat sink or heat rejector. And for an engine wherein the working substance may do work or have work done on it. Now, a thermodynamic cycle occurs when the working fluid of a system experiences a number of processes that eventually return the fluid into its initial state. Like for example, as we discussed here in the diagram, we have the engine. Then this is the Q added. Now for every input you have on the engine, hindi siya 100% convertible into work. Ang iba talaga ay masasayang, ang iba ay mapupunta sa heat sink. So that is the essence of your QR, which is your heat rejected. So therefore, applying conservation of energy rather, your QA equals your work plus your QR. So therefore, your work is your net work, and your QR is your heat rejected, and your QA is your input or your Q heat added. Now, for solving the efficiency of the Carnot cycle, you have to divide your output all over your input for you to know how efficient your engine is. The available energy is that part of the heat that was converted into mechanical work. That available energy is called the heat addition or the heat added. And for the unavailable energy is the remainder of the heat that had to be rejected into the receiver, or which is your heat rejected, the unavailable energy. Now, the second law of thermodynamics states that all energy received as heat by a heat engine cycle cannot be converted into mechanical work. So, meaning that just like what I said, na hindi lahat ng i-input mo sa engine ay convertible into a work. Meron talaga siyang masasayang. And that applies for the second law of thermodynamics. Now, for the work of a cycle, the work net is equal to your QA minus your QR. Pwede mo na din to i-disregard para hindi ka malito. So, your work net should be your QA minus QR. Why? Kasi, sinabi nga natin dito, applying the conservation of energy, your QA equals W plus QR. So, therefore, your W is QA minus QR. Now, next, the net work of a cycle is the algebraic sum of the works done by the individual processes. Like, for example, your work, summation of work 1 to 2, work 2 to 3, work 3 to 4, and so on and so forth. So, therefore, for each phase, for each process you have, there is an equivalent work. Like, for example, kung isentropic ba siya, kung isobaric ba siya, kung isometric ba siya, kung polytropic, or isothermal. May kanya-kanya silang work. So that is the summation of the work. Now, for the Carnot cycle is the most efficient cycle conceivable. There are other ideal cycles are efficient as the Carnot cycle, but not more so. Such a perfect cycle forms a standard of comparison for actual engines and actual cycles, and also for other less efficient ideal cycles, permitting us to judge how much room there might be for improvement. And for the operation of the Carnot engine. Now, this operation of the Carnot engine will best simplify into this diagram. So, papaliwanag ko how Carnot engine work and Carnot cycle work. Now, Imagine you have a piston cylinder on your mind. Or if kung hindi mo talaga ma-visualize ang piston cylinder, i-imagine mo you have a syringe or yung hiringgilya, yung paturok natin, na may karayo. Now, for the process 1 to 2, which is your isothermal heat, isothermal expansion, heat addition, so yung condition mo at 1 prime, at point 1, it should be initial condition, which is yung at rest, So since sinabi natin since ang Carnot cycle, the first process is expansion, the isothermal expansion, meaning at constant temperature, the piston expands. So therefore, itong hiringgilya mo, itong piston mo, pupunta siya sa 2 prime. So ibig sabihin, ano ang mangyayari dito sa loob ng iyong cylinder, ng iyong karayom, ng iyong panturok? So magkakaroon siya ngayon ng volume. Magkakalaman siya ng fluid. So therefore, your 1 to 2, magkakaroon ka ng accumulation ng volume. Kaya, mapapansin mo from 0, from at a given volume, tumaas yung kanyang volume. And then from process 2 to 3, which is the isentropic expansion, isinagad natin. We reach the piston into its top dead center. Kumbaga sa hiringgilya, kumbaga doon sa panturok natin, isinagad na natin yung pagsak ng fluid. Doon sa karayom. So therefore, punong-puno na ito ngayon ng fluid. So therefore, kung ito'y punong-puno ng fluid, na-reach na niya yung kanyang peak volume, which is your 0.3, your 3 prime. Kaya mapapansin mo, yung 3 dito ay siya na yung peak ng volume mo. And kung mapapansin mo, bumaba yung pressure kasi nga, lumaki yung volume. And now, for the process 3 to 4, which is the isothermal compression, heat rejection, na dito na yung process pabalik. Since na-expand mo na, now, all you have to do is to compress na, to push the liquid to its exit. So, ibig sabihin, from 3, pupush mo yung hiringgilya mo papunta dito sa 4 prime. So, ano mangyayari? Yung laman ng fluid na nandito sa hiringgilya mo will pressurize. Kaya, aangat yung iyong pressure. Kaya ganito yung drawing niya. And then, for 4 to 1, from 4 prime, isinagad mo na ulit, into its original form. As in, kumbaga, tinanggal mo na lahat ng fluid na nadoon sa loob ng hiringgilya. Pinasiritan mo na doon sa karayom, kaya nawalan na ng fluid at bumalik na ulit sa kanyang initial volume. And that's the process of the Carnot cycle and the Carnot engine. So therefore, your Carnot engine is equivalent to your, the processes of a Carnot cycle is isothermal expansion, heat addition, isentropic expansion, isothermal compression, heat rejection, and the isentropic compression. Now, if you master the drawing of the PV diagram of a Carnot cycle, it's very easy for you to know and to derive formula based on the diagram. Just always remember that ang heat added natin ay laging nasa process 1 to 2. At ang heat rejection natin ay nasa process 4 to 3. Hindi siya pwede, 3 to 4, hindi siya pwedeng magkabaliktad at mamamali ka ng sagot mo. Now, for the analysis of the Carnot cycle, you have your QA equals T1 and times S2 minus S1. Now, as you can see, sabi ko nga sa inyo, your QA should be in the process of 1 to 2. Since it is constant temperature, your T1 equals your T2. So, it's okay for you to put T1 or T2 times S2 minus S1, the same as your QR, which is in the process of 3 to 4. Since it is isothermal, you have T3 equals T4. So, it's okay kung T4 ang ilalagay mo or T3 times S4 minus S3. Now, for the work, dahil nga sinabi ko kanina, that work is equal to Q added minus Q rejected. Substituting your equation, we have a T1 minus T3 times S2 minus S1. Now, for the efficiency, which is your output over your input, which is your work net over your Q added. Then simplify, then substituting the equation, and we simplify, we cancel S2 minus S1. We have efficiency is equal to your T1 minus T3 over T1. So meaning, there are two equation na pwede gamitin mo to find the efficiency, which is the output over the input, or in terms of its temperature, which is T1 minus T3 over T1. Now, please bear in mind that yung T1 mo lagi ay yung pinakamataas na temperature. At yung T3 mo, yun yung pinakamababa. Ano? For a Carnot cycle. Kasi meron sa mga problem, binibigay na hindi agad sinasabi or hindi agad malalaman na yun pala ay T1. Ano? So, you assume na yun ay T1 agad. Pero yun pala ayun ay T3. Ano? So, lagi mo tatandaan na your T1 is greater or higher than your T3. Okay? Now, work from the TS plane. Your QA equals MRTL and V over V1. Now, pwede din siya gamitin mo yung PV. Why? Kasi, perfect gas equation tayo. PV equals MRT. Ano? ln V2 over V1. Now, for QR, MRT 3 ln V4 over V3. Now, again, I will be reminding you that wag na wag kayong magkakamali to use kung ano talaga yung mismong temperature niya at state point na gayon. Kasi for the QA, 1 to 2 yung process niya. So, dapat T1 at T2 lang yung gamitin mo. Pero sa QR, process 3 to 4 siya, dapat 4 at 3 lang yung gagamitin mo. Now, for the process 2 to 3, ang ano nga ba process 2 to 3 natin? The process 2 to 3 natin is the isentropic expansion. So, meaning, the formula or the relation between the T, V, and P sa isentropic process is this one. Ano? Your TVK and your TPK. Ano? Para hindi malito kung ano ang gagamitin, kung saan i-over yung K, meron tayo diyang reading. Ano? Si Theta Vk. Ano? TVK. Tapos ito naman si TPK. So therefore, yung i-over K mo ay si P, hindi si V. Ano? Kasi nga siya ay si Theta Vk lang. Ano? Si Theta Vk, TVK, tapos ito ay TPK. So therefore, from process 2 to 3, using a temperature and volume relation, pwede natin gamitin si Theta Vk, TVK, which is T3 over T2 equals V2 over V3 raised to K minus 1. And for the process 4 to 1, which is the isentropic compression, ganun din, the relationship between temperature and volume, si Theta Vk din, ano? TVK. Now, saan po natin ito kinuha? This formula derived from the 7 generals in the processes of ideal gas. Ano? Doon sa ating last past video. Doon sa processes of ideal gas. Ano? Na doon siya. Now, balik tayo dito, since isothermal process is from process 1 to 2 and process 3 to 4, therefore, your T4 equals T3 and your T1 equals T2. So, pwede natin itong pagdaupin, itong dalawang ito. So, therefore, simplifying it up, we have now a ratio of V3 over V4 equals V2 over V1. Now, ibig pala pong sabihin, sir, kung ating kukunin ang V4, kailangan natin munang hanapin yung V1, V2, and V3. That's correct. Sa process ng Carnot cycle or sa anumang magiging process, sa anumang cycle ng thermodynamics, you have first to find yung isa-isa nating state point. Uutay-utayin natin, himay-himayin natin. So, from point 1 to point 2 to point 3 and to point 4. So, you have to find all the parameters and all the required. Ano? And now, for the QR, which is negative MRT 3 ln V2 over V1. Yun lang yung kanina. And for the W, it equals QA minus QR or the MRT 1 ln V2 over V1 minus MRT ln V2 over V1. Now, your efficiency, which is W over QA, is T1 minus T3 MR ln V2 over V1 MRT1 ln V2 over V1, or equivalent also to your E equals T1 minus T3 over T1. So, pwede din siya, ganito ang formula mo. Ano? Now, from the work from the PV plane, it is the summation of work, meaning, since ang ating Carnot cycle is TS-TS, ano? Isothermal, isentropic, isothermal, isentropic. So, therefore, what is the work? What is the formula of work at isothermal process? Ito po, iyon. what is the formula of work of the isentropic process? Ito po yun. So what is the work at isothermal process? Ito lang din yun. And what is the work for isentropic process? Ito yun. Please bear in mind also yung ginagamit nating subscript. Ano? For every process, nag-iiba yan. Para kayo ay hindi malito at hindi magkamali, dapat you know what processes or what state point you are getting. Now, for the mean effective pressure, which is the PM, you have your work net all over your VD. VD is your volume displacement. So, paano po natin makukuha yung volume displacement? Let's go back here. This is your mean effective pressure, and this is your work. So, therefore, your VD is your peak volume minus your initial volume. So, therefore, your V3 minus V1 is your volume displacement. Okay? So, for the ratio of expansion and the ratio of compression, please bear in mind that, like for example here, isothermal expansion. Saan bang process or saan point ang isothermal expansion? Siya ay process 1 to 2. So, therefore, your ratio is V2 over V1. And for the isentropic expansion, saan ba natin makikita yung process na yon? 0.2 to 3. So, therefore, your ratio is V3 over V2. And for the overall expansion ratio, it is the highest, the peak volume all over your initial volume. So, V3 all over V1. And for the compression ratio as well, ganun din. Saan ba natin makikita ang isothermal compression? At 0.3 to 4. So, therefore, V3 over V4. And for the isentropic compression, saan ba natin siya makikita? 0.4 to 1. So, therefore, you have V4 over V1. And for the overall compression ratio, it is the peak volume all over your initial volume. So, therefore, your overall compression ratio and overall expansion ratio are the same. So, the isentropic compression ratio, RK, is the compression ratio most commonly used. So, therefore, if you're going to find RK, ito pala yung formula. So, ang RK, ang tawag ay isentropic compression ratio. Okay? Now, for better understanding, let's try to solve problem exercise number 1. Now, a Carnot engine operating between 775 Kelvin, which is your T1, and 305 Kelvin, which is your T3, produces 54 kilogram of work, which is your work net. Determine your Q added, your delta S during heat rejection, and your efficiency. Now, as you can see here, mapapansin mo talaga alin yung mas mataas sa temperature. So, 775 Kelvin yung mataas. So, therefore, siya talaga yung automatic na T1. And now, sir, ito po ba ay T2? No, this is not a T2 kasi ang ating Carnot cycle is, ang unang process is isothermal. So, therefore, constant temperature, meaning your T1 equals T2. Ang T1 nga natin ay 775. So, therefore, your T2 is 305 Kelvin. And your work is 54 kilojoule. Now, solving for the QA, paano natin mahanap yung QA? Ay, anong formula? Iisip tayo ng formula. Pwede bang QA equals W plus QR minus QR plus QR? Meron tayong W, wala naman tayong QR. So, hindi din pwede. So, let's try the efficiency. Efficiency equals 1 over QA. Wala naman tayong efficiency. Pero, binigyan tayo ng temperature. So, therefore, the efficiency is equal to your T1 minus T3 over T1, which is equivalent to 60.64. So, meaning you have your efficiency and now you can get your QA, which is work over efficiency, which is equal to 89.0426 kilojoule. And for your delta S in heat rejection, meaning saan bang process, saan bang point yung heat rejection makikita? Nasa process 3 to 4 siya, meaning siya ay isothermal process. And the formula for isothermal process in delta S is equal to your Q minus T. So, ang gagamitin mo ngayon ay QR kasi ang tinatanong, ang hinihingi sa problem is heat rejected. So, QR over T3 equals 0.1149 kilojoule per kilogram. Now, for a Carnot power cycle operates on 2-pound mass, which is your mass, tapos air. So, therefore, you have to know the values for air. The R, which is 53.34 for air. Now, there are other problems na sasabihin, helium. oxygen, nitrogen, hahanapin mo ngayon yung R nila by means of getting their molecular formula, tapos i-divide mo siya doon sa 8.315 all over your molecular weight sa metric system. While in the English system, it's 1545 divided by its molecular weight para makuha mo naman yung R nila. Then yung CVCP, given, dapat alam mo yung constant ng CVCP sa air. Whereas sa other gases, meron tayong formula ng CV and CP. Kung sa CP, since ikaw ay CP, ikaw ay mayaman. So CP equals RK, rich kid, RK over K minus 1. Tapos yung CV naman, yung isa ang gagamitin nating formula. Now, next, limits of 70 Fahrenheit and 500 degree Fahrenheit. Now, iisipin mo agad na ang T1 mo ay 70 kasi siyang unang binanggit. That's very wrong. Kasi nga, sinabi ko sa inyo, ang T1 natin yung pinakamataas na temperature. So therefore, your T1 is 500 degree Fahrenheit and your T3 is 70 degree Fahrenheit. The pressure of the beginning of isothermal expansion is 400 psi. Please take note that the isothermal expansion is from the process 1 to 2. Tapos siya ay beginning, so ibig sabihin, siya ay nasa unahan, 0.1. So therefore, P1 is 400 psi. And at the end of isothermal expansion, which is 0.2, therefore your P2 is 185 psig. Now, determine the volume at the end of isothermal compression. Hanapin natin kung anong point yung isothermal compression, which is 3 to 4. So therefore, at the end of the isothermal compression, hanapin natin ay V4. So paano pala yun, sir? Hindi hanapin natin yung V1, V2, V3 bago natin makuha yung V4. That's correct. So iisa-isahin natin, hihimay-himayin natin. So at point 1, using your PV equals MRT, you substitute all the values given, you have 1.778 cubic feet. And for the V2, PV equals MRT then, you substitute all the values given. Please take note that T1 equals T2 kasi isothermal. Ito. So therefore, your V2 is 3.5061 cubic feet. Now, for the point 3, since siya ay nasa isentropic expansion, TBK or TPK yung ating gagamitin. This time, since meron na tayong pressure na binigay, yung TPK ang ating gagamitin. Which is yung, meron na tayong P2, meron na tayong T2, meron na tayong T3. Wala tayo ay T3. So, yun yung hinahanap natin. And for the K, since siya ay 1.4 ang gagamitin natin. So, your P3 is 24.57 psia. Now, your V3 now, using the PV equals MRT, you have your V3 which is 15.72 cubic feet. And for the point 4, masasagutan na natin siya using yung ratio and proportion natin na V4 over V3 equals V1 over V2, which is equivalent to 7.8049 cubic feet. And for the change in entropy on the isothermal process, you have your MRL and V2 over V1, which is equivalent to 0.0952. And for your QA, since meron na tayong delta S, pwede natin gamitin yung delta S equals Q over T. So kung QA, T1 yung ating ipapartner. So therefore, your QA is 91.40P and naman ipapartner, which is your 50.46 BTU. And for the work net, which is QA minus QR, you have 91.43 BTU and 50.46 minus 50.46. So therefore, your work is 40.97. And for your efficiency, output over input, which is 44.81. And for the isothermal expansion siya, process 1 to 2, so you have V2 over V1, which is equivalent to 2. And for the overall expansion, your peak volume all over your initial volume, which is V3 over V1, which is equivalent to 8.84. And for the mean effective pressure, you have your work net all over your volume displacement, which is W all over VD, which is V3 minus V1. And you have your 15.88 PSI. So that's the problem of a Carnot cycle. Halos natakil natin dito sa problem number 2 yung lahat ng possible na pwede nating makuha sa Carnot cycle. So I hope you have learned from my video tutorial And please stay tuned and please like, share, and subscribe to my YouTube channel. Thank you very much and keep safe everyone.